Hello, everyone. Welcome again to CLSA's monthly webinar series. My name is Jeff Burgess. I am your Executive Director, and we appreciate you joining us today. Bit of housekeeping before we get started. Some reminders on the CLSA event calendar. We have tomorrow, the second of our Jeff Lucas workshops. Tomorrow's session, an all-day session, will be in Pleasanton, the 4 Points by Sheraton. Sessions were very well attended and enjoyed yesterday in Anaheim Garden Grove. Mr. Lucas got very high marks in the surveys after the session. So we hope if you're in Northern California and you can join us tomorrow, please come. We're pretty full, but I think we can fit a few more folks in. So if you're in Northern California, please consider joining us tomorrow at the Jeff Lucas workshops in Pleasanton. Wednesday, December 14th, the Phasing Boundary Surveys webinar will be at 11 o'clock. The presenter is Landon Blake. Wednesday, January 4th, a repeat session, one we did that was very popular earlier this year. Important changes in the PLS application process, presented by BPEL's-G Executive Officer Rick Moore. That's Wednesday, January 4th at 11. You may want to pass that on to folks that are going through the application for licensure process. Then March 24th through the 28th, very excited that we're going to conduct the CLSA annual conference at the Wyndham Anaheim Garden Grove. Getting our speakers together now, our exhibitors and sponsors, shaping up to be an excellent program, and we hope you'll join us. Again, that's March 24th through the 28th, just a stone's throw from Disneyland, the Wyndham Anaheim Garden Grove. Today's webinar, we encourage you to interact with our presenter throughout the webinar. If you want to ask a question, we have a question box that's available to you in your GoToWebinar dashboard. Enter your question there, and I will, if the opportunity presents it, I will ask the question during the course of the presentation. If I don't have an opportunity to do so at that time, I will save the question and ask it during Q&A at the tail end of the webinar. Also, at the during Q&A, you'll have the opportunity to interact with our presenter through the Raise Your Hand function. Again, just take a look at your GoToWebinar dashboard. Look for the attendee box. Raise your hand, and we'll selectively go through, unmute you, and you can ask your question yourself. Also, if you look in your GoToWebinar dashboard, you'll see there's a PDF version of the presentation you can download. And with all of our webinars, we will provide a link, hopefully later today, if not today, tomorrow, where you can view the recorded webinar via YouTube. With that, let me tell you a little bit about today's presenter, Dr. Mike Mustafa Berber. Dr. Berber received both his bachelor and master's degrees from Yildiz Technical University, Istanbul, Turkey. He got his PhD in Geodesy and Geomatics Engineering, University of New Brunswick, Canada. Following his graduation, Dr. Berber joined the Department of Civil Engineering at Ryerson University, Ontario, Canada. After having 7 long winters in Canada, more than I think I could endure, he moved to Florida and worked as an assistant professor at Florida Atlantic University. Dr. Berber has been a faculty member of the Department of Civil Geomatics Engineering at California State University, Fresno since 2014. His expertise is in geodesy, global navigation, satellite systems, geodetic measurement techniques, in hydrographic surveying. So with that, Dr. Berber, if you would please take on.
Okay, thank you. Can you see my screen and my cursor?
Looks terrific.
All right, thank you. So as you can see today, I'm going to talk about network RTK systems in California. And the RTK stands for Real-Time Kinematic Survey. I believe that some of you are familiar with these systems, and some maybe are running these systems, but this presentation is geared towards the ones who are not familiar with these systems. Therefore, I'm going to begin by giving some background information. In the past, or it may still be the case today, normally a surveyor would set up a base station in the project area, like you see on the slide. So we have the base station, and as you can see, the base station antenna is connected to the receiver. Receiver is connected to the radio, and radio sends the corrections to the rover. With this scenario, we are measuring the baseline between these two GPS systems. So in this scenario, as you can see, this is called single reference RTK station. In this setup, both the reference and rover are observing the same set of satellites. The reference station is sending all its position and satellite observations to the rover. And the rover combines these reference station observations with its own observations to compute an RTK position. So this is basically how single reference RTK setup works. Now let's look at advantages and disadvantages of this single reference RTK. Advantages are the principle is straightforward and generally well understood. Traceability can be maintained throughout because we know where the base station is set up, and the coordinates of the rover is determined with respect to the known coordinates of the base station. Disadvantages, the cost to purchase the reference station, the time needed to set up the reference station, and the most important one among these is as the distance increases between the reference and the rover, the accuracy of the rover's computed position decreases. And this is because mainly atmospheric errors and orbital errors. Essentially, as the distance between the rover and the reference station increases, the atmospheric conditions at the rover and reference station will become increasingly different. This decreases the accuracy and makes it more difficult for the rover to fix the ambiguities. So, to be able to minimize these distance-dependent errors, network RTK systems have been developed. So what is network RTK? As you can see on the slide, the definition is an RTK network is a network of permanent GNSS receivers which relay satellite data continuously to the central office, where the combined data is used to generate RTK corrections, and these corrections are sent to the rover. So these network generated RTK corrections are called network RTK. Network RTK systems can vary in size. They may cover a state or a country. So as you can see on the slide, we have a state example, which is Florida. This network is called Florida Permanent Reference Network. Actually, this image is a little bit old. I believe that there are more stations right now. But in any case, it is an example of a statewide network RTK system. This is the network RTK system from Sweden. Again, this image is a little bit old, but it is an example of a network RTK system in a country. So, as we stated already, in a network RTK system, reference stations, like you see on the slide, these reference stations continuously stream satellite observations to a central server that running network RTK software. So the aim of network RTK is to minimize the influence of the distance dependent errors on the rover's computed position. And this is done by the network RTK server by fixing the ambiguities of the satellites within the network and using the data from all or a subset of reference stations to generate corrections that are sent out to the rover. Then all what a surveyor needs to do is going to the project site and connecting to the network RTK server via one-way or two-way communication link. Nowadays, for this purpose, cellular systems are commonly used. Once the rover receives the RTK data, it computes its position. So basically, this is how a network RTK system works. Let's look at advantages and disadvantages of network RTK. Advantages are no need to set up a base station. The accuracies of the computed rover positions are more homogeneous. This is as opposed to setting up your own base station. And the accuracy is maintained over larger distances between the reference station and the rover. And this is the whole promise of the network RTK system, right? And the same area can be covered with fewer reference stations. Again, this is as opposed to setting up your own base station. And also higher reliability and availability of RTK corrections are achieved because if one station goes down, another can take over. The only disadvantage is the cost to subscribe to an RTK network. Now, let's look at network RTK methods, and you see 4 of them here. These 4 are the commonly used ones. So the first one in the list, as you can see, is MAX, which is the correction service which utilizes master auxiliary concept. The second one is IMAX, which stands for individualized MAX. And FKP is German acronym for area correction parameters. And the last one in the list is VRS, which stands for virtual reference station. Let's go through these methods one by one. Okay, as you can see, the first one we're going to look at is MAX, or individualized MAX. So how does this method work? As you can see, we have the reference stations. These are like the stations we saw in the example of Florida, but we live in California, right? So let's say these are the reference stations covering California, and rover is in the middle somewhere, let's say in Fresno. As we said, the reference stations relay satellite observations continuously to network RTK server, and using this data, the software RTK network RTK software produces the network ambiguity, and having received the approximate rover position from the rover, obviously, it prepares the network solution and generates the correction. In this case, it's generating the IMAX correction, and these corrections are sent to rover. So once the rover receives the RTK solution, it computes its own position, and as you can see, at the same time, both the reference stations and the rover are obviously observing the same common satellites. Let me tell you that the IMAX was developed at the same time as MAX to support older receivers that cannot support the MAX corrections. So as you can see on the slide, the corrections are sent to the rover from a master station. This means that the baseline between the master station and the measured point can always be directly remeasured. Therefore, the measurements are traceable and repeatable, and this is a survey requirement which was mentioned by the previous speaker, Gregory Helmer. And the Gregory Helmer pointed out that this is a listed requirement in GNSS surveying standards and specifications. So IMAX uses RTCM messages and requires bidirectional communication between the rover and master station. So what is RTCM? The long name, as you can see, is RTCM SC104, which stands for Radio Technical Commission for Maritime Services Special Committee 104 format. So this committee developed this format for real-time differential GPS operations. So basically, this format is used to send the corrections to the rover through a communication link. And if you look at the format, the format itself consists of 64 message types, which I don't want to go into detail in this presentation. But the examples from the 64 messages are reference station parameters, differential GPS corrections, etc. And these are what we need to transmit here too, right, from our base station to the rover. And if you are interested, you can find the detailed information on rtcn.org website. Okay, moving on to VRS method. Again, with the VRS, the initial process is the same, meaning that the reference stations are sending the satellite data to the network RTK server, and network RTK server calculates the network ambiguities and then prepares the network solution, having obviously received the approximate rover position, and then generates this time virtual corrections. And these virtual corrections are sent back to the rover. Actually, a station, a virtual reference station, very close to the rover, which is only a few feet away from the rover, and similar to the IMAX, both the reference stations and the rover are observing the same common satellites. VRS and IMAX are similar in the sense that in both methods, the rover sends an approximate position to the server. Again, in both methods, the server calculates the network solution to reduce the dependent errors. In other words, the network solution is not optimized for the rover's position and might be limiting the RTK solution. The IMAX and VRS methods are similar but not identical. The major point of difference is that the IMAX method generates corrections for a real reference station instead of a virtual reference station. All baseline length dependent errors in the VRS, still we are talking about VRS, right? Such as tropospheric variation, ionospheric disturbances, and orbital errors are removed from the VRS because the virtual base is so close to the rover. So remember, this was the whole promise of the network RTK system, meaning that we want to minimize the distance-dependent error. So VRS achieves this by creating a virtual reference station very close to the rover. Again, VRS data is supplied as RTCN messages, but the rover sends the position to the network in a NEMA format. That is NEMA format. Again, the name is NEA0183, which stands for National Marine Electronics Association 0183 format. And this format is actually data streams in ASCII format from a talker, in this case GPS receiver, to a listener. In our case is the server, right? But it can be sonar or multiple listeners. And this format may include information on position, speed, depth, frequency allocation, etc. So in our case, the rover is sending its position to the server using the NEMA format. Okay, let's continue with FKP. Again, the initial process is the same. The data comes from the reference stations to the network RTK server. Network RTK server calculates the network ambiguities, but this time there is no approximate position coming from the rover, although it wouldn't hurt. But with the FKP method setup, the network creates the solution without having the approximate position, and then generates this time obviously the FKP corrections. And these corrections are sent back to the rover, and rover, having received these corrections, rover computes its position. And again, both the reference stations and rover are observing the same common satellites. So in FKP method, the server models the distance dependent errors and sends RTK data from one reference station within the network to the rover, along with the model. The FKP method creates area corrections that are valid for a limited area around a single reference station. So in this method, the server calculates the network solution to reduce the distance dependent errors. This means that the network solution is not optimized for the rover's position and might be limiting the RTK solution. Typically, the correction parameters calculated at the server are based on the assumption that the distance-dependent errors change linearly among stations. However, interpolation errors will occur at the rover if the true errors are nonlinear, and this can result in poor position quality. The FKP method sends all data from one reference station to the rover, as you can see on the slide. Okay, last in the series is MAX method. Again, the same thing is happening at the beginning. The permanent GNSS receivers are sending the satellite data to the network RTK server, and then the network RTK server is computing the network ambiguity. Again, there is no approximate position is needed, although it can be incorporated. And then the server generates the MAX corrections and sends this to the rover, and rover computes its final position having received the MAX corrections. Again, the same common satellites are observed by both reference stations and rover. So in the MAX concept, the network RTK server sends full raw observations and coordinate information for a single reference station, which is a master station, as you can see, and the other reference stations are considered auxiliary stations, as you can see on the slide. So all other observations are leveled to the master station observations and then transmitted. The master auxiliary concept gives the rover the flexibility to perform either a simple interpolation of the network corrections like FKP, or a more rigorous calculation for example, letting rover calculate multiple baselines from the auxiliary reference stations. This means that the rover can monitor the RTK solution and change its calculation on the fly to optimize the RTK solution, and this is a major advantage over FKP and any other method. So if we want to summarize the MAX method, MAX sends all the data to the rover, and rover does the bulk of the computations. Okay, having going through the RTK methods, now let's look at the network RTK systems in California. And Trimble is the first one in the list, as you can see. And this is the Trimble network in California, as you can see. And I obtained this image from this URL. So if you want to have detailed information about the Trimble network in California, so you can copy and paste this URL and then find out the detailed information. So among the methods, 4 methods we went through, Trimble sends VRS corrections and FKP corrections. It doesn't use MAX or IMAX, although Trimble has RTCM3net, which is equivalent of IMAX. And I also pointed out the datum for Trimble, which is N8083 2011, as you can see, that's the adjustment. And the epoch is 2011. I wanted to point this out because as we look at the following networks, although the adjustment is the same, epoch is different. Okay, second in the list is Leica. And as you can see, this is the Leica network in California. And I obtained this image from the URL, as you can see above. And again, if you want to find out the detailed information about Leica network, I recommend that you should use this link. So among the 4 methods, RTK methods we went through, Leica sends MAX, IMAX, and VRS. If you request FKP, then they can generate it for you. That's what I did when I was in Florida. I requested the FKP corrections, and then they enabled me to receive those as well. So basically, Leica sends all these for RTK corrections. And the datum for Leica is N8083 2011, but epoch is different, as I said. Epoch is 2015.25. And the last network we have, network RTK system we have in California, is TopCon network RTK system. And you can see the TopCon network in California. Again, detailed information about this network can be found in the URL above. And the TopCon only sends the VRS corrections. Again, the datum for the TopCon, the adjustment is the same, N8083 2011, epoch is 2010. So let's say if you want to coordinate a point using all these 3 methods. If you use all these 3 methods, you will get slightly different results because of this different epoch. And I'm going to explain it with the following slides, what you can do in this case. But before moving on to the next slide, let me point out one more thing. That is CTRN. You know, we have that California real-time network also covering the entire state of California. But it doesn't work on a network system. That's why I didn't include it to the slides. Because CTRN works on the single RTK reference system. That is the one we just talked about at the beginning of this presentation. Okay, to transform the coordinates across time from epoch to epoch, as I just pointed out, you can use the HTDP software from NGS website. And as you can see, HTDP stands for horizontal time-dependent positioning. But recently we've had a better one, Trans4D. Basically, Trans4D does the same thing that HTDP does, but it does more than that. So it transforms the coordinates in 3D. So the HTTP was 2D, Trans4D is 3D, plus it provides velocities from some part of Canada, and also it provides the standard deviations for the velocities. And if you are interested, you can find the detailed information from Snai et al. 2016. Okay, I just wanted to show you that I did a research about these network RTK systems that we went through, and I compared them in Florida. And published this in a measurement journal, as you can see, in 2013. And I extended this research to 1 year and collected monthly data, again along the same line in Florida. And this time I examined the atmospheric effects on the network RTK system in Florida. So if you have any sleeping problem, I recommend them before bedtime. That's it. Thank you for your attention.
Okay, Dr. Berber, thank you. I'm going to, we don't have any questions posed in our question box yet, but I will survey the attendees and look for raised hands. See if there's any questions so far. Feel free to enter your questions into the question box or raise your hand and pose a question directly to our presenter. Here's a question coming in. How do Leica, Topcon, Trimble satisfy public resources code regarding SPCs 8801 through 8819, or do they?
I'm not familiar with those. If you can tell me more about those, maybe I can answer.
Okay. Yeah, it might be wise. I don't know if you want to pose the question over your, raise your hand if you want to pose the question further verbally. Don't see any got another question here. I'm going to unmute Richard Maher. Rich, go ahead.
Kind of build off the question that was asked about the PRC. I think I can answer that. Primarily the private networks don't comply with the PRC in respect you're not getting a direct tie to a point that that satisfies the requirements for inclusion in the CSRS. But for the most part, you can look at these RTN systems as a measuring tool, and thereby you could tie to passive stations, or perhaps, as we do at my company, we reposition these stations ourselves so they have direct ties to points that do comply in the CSRS, and that therefore we get an answer out of the RTN. But we don't accept, as Dr. Berber was going through, we don't accept the positions that the provider is giving us in any of those various epochs. We would establish our own positions for those and then draw an RTK network vector off of that. Thank you.
Thank you, Rich.
Okay, thanks, Rich. And did get acknowledgement from the original questioner that that answers it, and thank you. Any other questions that you folks would like to pose to our presenter today? can raise your hand. I can unmute you as I just did with another attendee, or you can pose your question in the question box. Well, we've got one follow. Again, it's Rich Maher. Rich, go ahead.
Dr. Berber, in one of the various types of solutions you were talking about, and I apologize, I was driving back from a job and listening to this, it sounded like you were saying that a rover could have the capability to generate a vector from various stations in the RTN, as opposed to just a single vector from one of the stations. Is that what you were saying, is given the right software in my rover, could I, in the same way that perhaps I might use the CRTN because I can select individual stations instead of just always be given the single closest station, is there a real-time network solution process for getting vectors from various base stations instead of just a single vector?
Actually, that is done by the network RTK server automatically. So when the rover sends its position to the central office, the network RTK software picks the closest one to the rover and sends the corrections through that station. And as you move along the project site, that station might change as you move farther and farther from the first picked reference station.
Rich, you remain unmuted. Go ahead.
Oh, thank you. I'm sorry. Thank you. Okay, so I will still be getting so for a single position that my RTK rover is at, I will generally only be receiving or being able to bring into my post-processing software a single vector. I couldn't get another vector from another station unless I was being provided a method by which to select that station, which in my experience, at least with the Leica and the CalVRS ones, I don't get that. I get only the nearest stations. I can't produce two vectors essentially, and it sounds like that's what you're saying, and that's been my experience. I thought I heard something different.
Okay, let me explain on that more then. You don't need to, first of all, because from whichever reference station you will get the corrections, it will be the same, because that's the whole promise of the network RTK system, because once the network software computes the integer ambiguities, the solution will be the same, whether you get from the one reference station or later on from another one. Ideally, they will be all the same. So you can get from one station or from two stations, or as you move on, you will get from several other reference stations. But generally, the software picks the closest one for the rover, and therefore you see that during your surveys, you see that you are getting the corrections from the one reference station. But as I said, it will be the same if you get it from more than one stations, because the network software levels these corrections and then sends it from via one station, which is the master station. And it depends on the method among those four you are using.
Yeah, thank you. I understand that, you know, I'm not getting in a single baseline solution. I'm not simply getting the solution at the station. I'm getting something modeled. There's just something of a comfort level of, and let me be clear, I do use RTN networks, various ones on a regular basis, but there's something of a comfort level of being able to feel like you're adding that redundancy by having a second observation or third observation at a different time from another station that may be at the same distance, that you would have the same confidence in its position. So that, I was just curious when I heard there might be an opportunity to get that network correction from two different base stations, but I understand it. Thank you.
Thank you.
Okay. We've had a power outage here at the central office, so I'm just dialing back in on my cell phone and hoping that I'm viewing the question pane correctly. don't see any additional or other hands raised. I don't see any questions in the question box. Folks, here's your opportunity to pose a question to our presenter today. If we don't have any additional questions posed, we'll wrap up for today, and look forward to hearing from you and having you join us at a subsequent webinar. Okay. Well, Dr. Berber, thank you so much for your time and presentation today, your expertise. It's truly appreciated. Folks on the call today, keep an eye out for links to be emailed to you today or tomorrow with the webinar recording, as well as an additional opportunity to download the presentation today. Again, please visit the CLSA website, californiasurveyors.org, to register for future events, including tomorrow's Jeff Lucas workshops, our regular webinar series, and of course the 2017 annual conference. We appreciate your time and attention today. Dr. Berber, thank you again for your presentation.
Thank you for having me over.
And we will we'll look forward to having you folks join us again at a future date. Have a great day.